Today's lesson is 2-A Algebra Tiles. Our objectives today, or what we want to be able to do when we get finished, is we want to be able to use algebra tiles to model solving equations. And then tomorrow we're going to use the dry erase boards to model problems. First of all, we're going to go back and review naming algebra tiles and the different pieces of algebra tiles. The first one is the x squared piece. That's the big square piece. And we also have the negative x squared piece that's shown in red or in your notes to be shown by it being shaded. We have the green x piece, which is a rectangular piece. And then we have the negative x piece, which is also a rectangular piece. But it is also red to show that it is negative, or again in your notes it should be shaded. We have the positive unit piece, which is yellow, and then the negative unit piece, which is red. The negative 1 unit piece is red, or should also be, again, denoted by having it shaded in your notes.
All right, so on your paper, again, like we said, this should be your regular positive, and then your negatives should be shaded like so. Alright,
we're going to again review zero pairs. A zero pair is when you have a positive piece and a negative piece. So if you have a positive x squared and a negative x squared, those are going to cancel. Or a positive x and a negative x are going to cancel. Or a positive unit piece and a negative unit piece are also going to cancel. So they're called zero pairs because they zero out. Our first problem is going to be x plus 3 equals 8. Okay, you're going to set this up using the t-bar. And on the left-hand side, you're going to show what x plus 3 would look like using the algebra tiles. You have one x piece and then 3 positive unit pieces on the left-hand side of your t-bar. And then on the right-hand side, you're going to show 8, which would be 8 positive unit pieces. To solve an equation.
So just to clarify, I'm going to write this out for you so you know exactly what you're dealing with. Basically, like we said, this t-bar here is going to be your equal sign. So you have x plus 3 on this side of the equal sign, and then you're going to have an 8 on the other side of the equal sign because that's what you have in your problem. You can put your x piece here. Again, it's rectangular and it's a positive x, so we just put an x in the middle of it to denote that that is our x. And then you're going to have 3 unit pieces, so you have 1, 2, 3, and put your little ones in there so you know that those are your unit pieces. Then on this side, we have 8 unit pieces. So go ahead and write those out in your notes and go ahead and put the 1 in there as well to show those unit pieces. Now let's look back at the PowerPoint to see how to work out the problem.
Okay, and we talked about how when we have x plus 3 equals 8, in order to solve that equation, we need to get that x completely by itself on one side. So we need to get rid of that plus 3, or those 3 positive unit pieces. To get rid of 3 positive unit pieces, we need to zero those out or make those cancel, so we're going to put in 3 negative unit pieces. Now whatever we do to one side of our equation, we must also do to the other, so we're going to put in 3 negative unit pieces on the left and 3 negative unit pieces on the right. Then we're going to find our zero pairs and we're going to circle them. So we're going to find all of the zero pairs that we have. So we're going to find those zero unit pairs that we have, or those zero pairs that we have, and we're going to circle those. And in the PowerPoint, they're actually going to disappear to show that they zero out, and in your notes you can go ahead and just X those out to show that they are canceling. So again, they disappeared, and what we have left is our answer. And we know that we're done because our X value is by itself. So we have X, and then our t-bar, which is our equal sign, and then we have 5 positive unit pieces. So our answer to this equation is x equals 5. We know that this is true because if we plug it back into our equation, for x, if we put in a 5, 5 plus 3 does equal 8. This is problem number 2. It's x minus 5 equals negative 1. So again, on the left, we're going to show that using an x piece. An x piece and 5 negative unit pieces, and on the right hand side we're going to show 1 negative unit piece. Also go ahead, it says adding the opposite there at the top. Anytime you see a minus sign, you can change that to plus and negative. So instead of minus 5, we're going to look at that as plus negative 5 so that we know that we're going to have 5 negative unit pieces instead of 5 positive unit pieces. So again, we want to get that x value, or that x by itself, and we have 5 negative unit pieces attached to it. So to get rid of 5 negative unit pieces, we're going to put in 5 positive unit pieces. Remember, whatever we do to one side of the equation, we must also do to the other. So we're going to put in 5 unit pieces on the left and 5 unit pieces on the right. Then again, we're going to find those 0 pairs, and we're going to circle them because they're going to zero out or cancel. So we're going to circle all of those and either remove them or X them out in your notes.
Again, they disappear on the PowerPoint.
And what we have left is our answer because our X is now by itself. So we have X and then our T-bar, which is our equal sign, and it equals 4 positive unit pieces. This is example number 3. Take just a moment and see if you can
Go ahead and take a moment and see if you can write this one out on your own. You can pause the video now. All right, so on your paper, take a look at number 3 with me. You may not have set yours up exactly like this, but for the purpose of this problem, it actually needs to look like this, where your x's are horizontal, and then you have your negative unit pieces broken up into 2 different groups. You'll see why in just a minute, but if you didn't set up your problem like that, that's okay. Go ahead and fix yours to look like this. You can pause the video if you need to do that to get that fixed. Okay, so our goal is to get the x by itself, and we know here in this problem that we have 2 x's. They're together, written as 2x. We have to divide them, separate them. They're being multiplied, and the opposite of multiply is to divide. So we need to separate them, and we'll also separate our unit pieces into 2 equal groups. So we can divide our x's, and we show that by just drawing a line in between them, and separate our unit pieces, divide them as well into 2 equal groups. So you have here x equals negative 2, x equals negative 2. So for every 1x, we have negative 2. And you can go back and check that by plugging it into the original problem. When you look at it, 2, negative 2 for x equals negative 4. 2 times negative 2 is negative 4. Negative 4 equals negative 4, and that problem does check out.
All right, this is question number 4, and it says x divided by 3 equals negative 6. This is the most complicated problem that we're going to do using the algebra tiles. Again, we're going to go ahead and set up that T-bar. This can also be written a little bit differently. Instead of x divided by 3, we can also write that as 1/3 times x equals negative 6. So we're going to go ahead and write one complete x piece. But in this problem, it's not the entire x piece, it's 1/3 of that x piece equals negative 6. So we're going to split this x up into 3 equal groups. This first one is 1/3 of that entire x piece, and it's going to equal negative 6 unit pieces. Then we're going to take another 1/3 of that x piece, and that's going to give us another negative 6 unit pieces. And finally, we have one more third of that x to make the entire x piece, and that's going to be another negative 6 unit pieces. So the entire x piece altogether, because I have a third, and a third, which is 3/3 or the entire x piece, and the entire x piece is going to equal negative 18. So our answer here is x equals negative 18. If we plug that back in and we say negative 18 divided by 3, that does actually equal negative 6, so that it can be checked. So we've gone over our objective. We want to be able to use algebra tiles to model solving equations.
And tomorrow in class, we're going to go over using dry erase boards to model the problems. Thank you for watching.